if you haven't submitted, please do so before 11 a.m. today. It will take me a while to mark. Good morning, Veronica. Yeah, it will take me a while to mark all of them because, as you know, quiz 3 is a little bit more detailed than the 2 previous quizzes that you did. So I'll try to email you the marks today, but if not, I will do it tomorrow, okay? Because I need time. There are about 90 students taking this course, so I have to do it. I'll try my best to complete today. All right. So, all right. Let's summarize what we did last week. Last week I talked about portfolio theory, and there are 6 cases you may recall. Sorry. Let me start recording. Yeah, there are 6 cases in the portfolio theory. I covered the first 4 cases last week, and in this week or today I'm going to talk about the last 2 cases, which is case 5 and case 6 of portfolio theory, right? And so before I can talk about case 5 and case 6, I need to talk about some preliminaries which you might have covered in other courses you've taken. So let's go through the preliminaries. The preliminaries are about basically the joint. If you have a random vector x comma y or x1 comma x2, there's something known as the joint distribution function or joints, and there's also something known as joint survival function. And there's also a relationship between the joint CDF and the joint survival function. There are 2 kinds of relationships. So I will talk about them briefly. I hope you guys watched this video. There are 3 videos I asked you guys to watch. I hope you watched all 3 of them, and and I also asked you guys to email me questions you guys have any, or I haven't received any emails from you saying that you did not understand anything. So, but if you have questions today, please feel free to ask me about stuff that you did not understand in the 3 videos I asked you, right? All right, this is the first video, which is about preliminaries, right? So in the bivariate case, in the bivariate case, if you have a random vector x1 comma x2, this is known as the joint CDF, or the joint cumulative distribution function, and these are the marginal CDFs. And there's also something known as the joint survival function, which is defined by this and is denoted by f bar. So instead of f denotes the joint CDF, whereas f bar denotes the joint survival function and is defined to be this. And there are also marginal survival functions, which are this and this, right? All right. The marginal CDFs can be obtained from the joint survival function through these relationships, right? And there is a relationship between the joint survival function and the joint CDFs, which is this one, and vice versa. There's a relationship expressing the joint CDF in terms of the joint survival function, which is this one. So this is the reverse of this. So this one expresses the joint survival function in terms of the joint CDFs, and this one expresses the joint CDF in terms of joint survival functions. And the joint PDF, the probability density function, can be obtained using one of these formulas, right? Okay, that's in the bivariate case. Now, in the trivariate, when you have 3 variables, say x1, x2, x3, right? You have the joint CDF is defined by this equation here, right? And the marginal CDFs are this, this, and this. The joint survival function is defined by this equation. Again, you have a F bar. Bar on top means survival function, right? And the marginal survival function can be obtained from the joint survival function using these equations. Right? And once again, there are two relationships. The first relationship is that it expresses F bar, which is the joint survival function, in terms of the joint CDFs. And the second relationship expresses the joint CDF in terms of the joint survival function. So this is the reverse of this, right? Both these are useful, as we will see later. And there's also the joint probability density function, which can be obtained using one of these formulas, right? Okay, guys, any questions so far? Am I going too fast?
The bottom of that last page,
Oh, yeah, it should be 3. Yeah, you're right. Thank you, Robert. It should be 3 here, because it's differentiating with respect to 3 variables. Yeah. Any other questions? Thank you for this. Yes. Right, so that's in the trivariate case. Now, in the general case, which is p-variate, when you have p random variables like x1 to xp, the joint CDF is defined by this equation. The joint and the marginal CDFs are defined by these equations. The joint survival function is defined by this equation. So you have F bar, meaning a joint survival function. And the marginal survival functions are defined by these equations, right? And once again, there is a relationship between, hope you can see this, yeah. Once again, there is a relationship between the joint CDF and the joint survival function, right? And it's this one here. So this relationship, it expresses the joint survival function in terms of the joint CDFs. And this relationship here expresses the joint CDF in terms of the joint survival functions. And once again, in order to compute the joint PDF, you can use one of these two relationships, equations, okay? So we talked about the bivariate case, the trivariate case, and the p-variate case. So in each case, I showed you how the joint CDF and the joint survival functions are defined, and what the relationship between the two are, right? In other words, if you know the joint CDF, you can work out the joint survival function and vice versa, using the relationships, right? And this is example, one of the examples I did in the video. I hope you guys watched these examples, so I'm not going to go through it. This is the second example I did in the video. There are so few people today, I don't know why. This is the second example I did in the, right? I hope you watched that too. All right, now, so that's the first video. I asked you guys to watch the preliminaries for case 5 and case 6. So now let's go to case 5. Now, you may recall from last week that the case 5 of portfolio theory is about where the losses in the losses of the investments are dependent random variables, and the number of investments is fixed, right? You remember that, right? So in this case, the CDF of remember, S is the total portfolio loss. The CDF of S is given by this. Once again, I don't expect you to know how to derive this, but you should know how to apply this if I give you an example, right? So this is the CDF of the total portfolio loss, and this is the PDF of the total portfolio loss. Okay, case 5. And this is an example. I hope you watched this example in the video. Now this is the CDF of U. Remember, U is the minimum portfolio loss, and you can do, again, I don't expect you to know the derivation, but if you can understand the derivation, that's good. The final formula for the CDF of U is given by this. Here, F bar denotes the joint survival function of x1 to xn, right? The formula for the PDF of U is given by this, right? And finally, the CDF of V, remember V is the maximum portfolio loss, and the final formula for the CDF of V is given by this formula. Here, F is the joint CDF of x1 to xn, right? And the formula for the PDF of V is given by this, right? This is an example I did in the video. I hope you watched this example. So I'm not going to go through it. Okay. All right. Now, finally, the case 6. Case 6 is the most general of the 6 cases. Is where the losses of the investments are dependent random variables, and the number of investments is also a random variable independent of the losses, right? Okay, in this case, the CDF of total portfolio loss is given by this formula, right? Again, you don't need to know the derivation, just try to only to know how to apply. The PDF of S is given by this, yeah. The CDF of U, remember U is the minimum portfolio loss, is given by this formula here, and the PDF of U is given by this formula here, right? Okay. And finally, the CDF of V, the maximum portfolio loss, is given by this formula here, and the PDF of V is given by this formula here. All right, so these are the 3 videos I asked you guys to watch. I hope you did, and if you have questions, feel free to ask me now. You can ask me before I move on to do some examples. Do you have questions? Those you guys on Zoom, you have any questions on the 3 videos? Hello guys, talk to me. You guys in the Zoom. Okay, now what I'm gonna do, guys, is to do some examples, right? So let me start with one example. Example 1. Hope you can see this. Example 1. So the examples I'm going to do today are on case 5 and case 6, okay? So you should know the formulas you're going to use. right? So this is the question. So you have a portfolio with two investments, and the losses are denoted by x1 and x2, and you're told that the joint survival function of the losses is given by this, right? And the question is to find the distributions of S, U, and V. So the total portfolio loss, the minimum portfolio loss, and the maximum portfolio loss, right? Now first, let's start with S. In order to find the total portfolio loss, you need to work out the joint P. You should look at the formulas that I showed you earlier. Let me go. So this, by the way, this is case 5, yeah? Because you have number of investments is 2, which is a fixed number, right? So you should go to case 5, which I showed you earlier. Let me try and find where it is. Where is it? Here. Look, this is case 5. Okay, this is case 5 of portfolio theory. And in order to find the CDF, you need to first derive the joint PDF of the losses, right? So that's the first thing you must do. What you are given here is the joint survival function, right? So in order to find the distribution of S, we need to find the joint PDF of x1 comma x2. And for this I gave you a formula earlier, if you should recall. This is the formula I gave you earlier. You should look at the first video I talked about today. This is the formula. Right? It's a double partial derivative of the joint survival function. Right? Now, first of all, if you differentiate with respect to x2, you get this is what you get, right? Now, if you differentiate with respect to x1, you will get minus a minus 1 okay, guys, so this is a times a plus 1 of 1 plus okay, like this. Okay, guys. Now, in order to find the joint, or the PDF, the PDF of S. The PDF of S is now. Okay, let me draw you a picture here. Let me draw a picture here. This is you have two variables. You have a variable x1, you have a variable x2. And if you look at this line, this is the line where x1 plus x2 is equal to S, right? So in order to find the PDF of S, right? Well, you need to integrate over this line, right? So basically you need to, what you need to do is the following. You need to right, look, integrating over this line is the same as this integral here. So you're integrating, you should take this to be, this to be x. The value of this will be s minus x, right? So if x1 is equal to x, x2 will be s minus x, because they must add up to s, right? So the PDF of s is just basically the integral of this for x from 0 to s, right? So this will be, and you guys see me, if you can't see me, let me know. A times a plus 1 plus x plus s minus x minus a plus 2 dx, right? Right, now this is gonna be a times a plus 1 is a constant. The x cancels, so 1 plus x, 1 plus s, this is, you can take it outside, and inside you have just the integral of 1 times dx, right? And the integral of 1 from 0 to s is simply s. So the answer is so this is the what I have written here is the PDF of the total portfolio loss. Do you see how I got it or not? Are you okay with that? Okay. Right. Now, in order to find the CDF, you can do this. Let me find some paper. Can I take this? Okay. In order to, so what I have, so let me write down one more time. So the PDF of S is, oh, by the way, this should be S, not X. So this should be X, S, right, not X. So correct this issue. Sorry. So the PDF of S is right. Now to find the CDF, what you need to do is you need to integrate the PDF from 0 to S. So if you do that, you will get a times a plus 1 0 to s 1 plus t power minus a plus 2 t dt. Okay, all right guys, so now how can you do this integration? Any ideas? obviously you need some kind of substitution, right? Um,
You can sort of like gamma thing.
Not really, not gamma, I don't think so. It's more like beta function. So you can make a substitution. The substitution I will try is the following, is I mean, once again, you learn this by experience. Let's try this substitution, that y equal to t divided by 1 plus t, right? So that means 1 over y is so 1 over y minus 1 is 1 over t, and t equal to y divided by 1 minus y. Okay. Now dt is the dt by dy is going to be the derivative of this. It's going to be y minus 1 plus 1. If you do the differentiation, I think this is what you will get. Okay, correct me if I'm wrong. Maybe y minus 1 plus. Yeah, I think so. So let me put this in a box. If I put this in a box, right, you'll get this to be, if you sub this into the integrand, you get a times a plus 1. The limits of integration will go from 0 to s divided by 1 plus s, and 1 plus t will become 1 minus y to the power a plus 2, and t will be y divided by 1 minus y, and dt will become dy divided by 1 minus y squared. Okay, sorry, I'm doing it in a rush, sorry, excuse me for that. So if you simplify things, you get, this is the integral from 0 to this of y 1 minus y a minus 1 dy. Yeah. Okay. All right, guys. So now this integral, it may be familiar to you. I think this is known as the. Okay, let me write it down. This is actually known as the incomplete beta function, and is defined as this. It's known as the incomplete beta function. Let me put this in a box. Yeah, so using this definition, you can write this integral here as follows. So this would be a times a plus 1, the beta function divided by s divided by 1 plus s, 2 comma a. Right. All right, guys. So that's the CDF, or the cumulative distribution function of the total portfolio loss. I know it looks complicated, but it's not. Once you start doing this, it shouldn't be too difficult. All right, so we are done only the first part. Now the second part of the same question is to find the CDF and the PDF of the minimum portfolio loss. Are you guys following this or no? You okay? Yeah, okay. All right, let's go to the second part of the question. So the second part of the example is to find the CDF and the PDF of U. Remember, U is the probability. Sorry, what am I saying? Okay, this is the CDF by definition. Okay, now you can write this as 1 minus the probability that capital U is greater than U, and this is 1 minus the probability that the minimum of x1 comma x2 is greater than U. Yeah, are you guys with me? Now if the minimum is greater than U, then it must imply that x1 is greater than U and x2 is greater than U. Okay, let me take this away. All right, now if you go back to the first video I talked about today, what do you know about this probability here? This is what? It's something I talked about very early today. This is the joint survival function of x1 comma x2 at U comma U. Yeah. Now if you go to the example actually gives the joint survival function as this, right? So basically this is 1 minus 1 plus U to the power minus A, which is 1 minus 1 plus 2U to the power minus A. All right? So this is the CDF of minimum portfolio loss, and the PDF of U it's just the derivative of it's the derivative of the it's the derivative of this, which is minus 1 plus 2U. There should be A here, sorry, A minus 1 and times 2. So and there should be minus, so it makes plus. So this will become 2A 1 plus 2U to the power of this. Okay guys, so that's the density function of the minimum portfolio loss. So that's the second part of example 1. You guys okay with this? Now the third part of this example is to find the CDF and the PDF of the maximum portfolio loss, right? So that's what I'm gonna do here now. So the CDF of V is this, yeah? Yeah, sorry, can't see it. Right, now V, as you know, is the maximum, so it's the maximum of the x1 comma x2. less than or equal to v. Right, so this implies that if the maximum is less than or equal to v, then x1 has to be less than or equal to v, and x2 has to be less than or equal to v. Now this, if you go back to the preliminary video that I went through this morning, this is exactly equal to the joint CDF of x1 and x2 at v comma v, right? You follow me? That's what I did. Now, if you return to the question here, the question does not give the joint CDF. It only gives this is the question. The question only gives the joint survival function. It doesn't give you the joint cumulative distribution function. So this is where you need to use the relationship that I mentioned earlier today, that there are relationships expressing the joint CDF in terms of the joint survival function and vice versa, right? So this is where we need to use the relationship, which if you look back earlier what we did today, this is the relationship I'm just writing it down without looking at it. I hope it is correct. This is the relationship that expresses the joint CDF in terms of the joint survival function. I mean, if you look back what we did earlier, you will see this. This is one of the relationships I gave you earlier this morning. Okay? Yeah? All right, now each of these guys we know, because we know the formula for f bar, which is given in the question. So this is going to be 1 minus, using the formula given in the question, is 1 plus 0 v minus a 1 plus v plus 0 per minus a plus 1 plus v over minus a. Okay, so this will be 1 minus 1 plus v minus a, and there are two of them, plus 1 plus 2v. So this is the CDF of the maximum portfolio loss, right? Now to find the PDF, you need to differentiate this with respect to v. Alright, so and if you do that, this is what you will get. I'm going to do it quickly. So it's going to be 2a 1 plus v, and then minus 2a 1 plus 2v. Okay, is that right, guys? Check my calculations. So that completes the question example 1. All right. So let me see if I can find an example. Are you okay with this, guys, or you have questions? You have questions in this with the example or not? Are you guys okay? Yeah. All right. So this is a typical example you may get in the exam or something like that. I don't know. Like if you look at the past exam papers, I think there are the last 6 or 7 years. I have them on the course website. You will see there are many questions on portfolio theory, similar to the one I did today, right? So you should be able to go through them. Yeah. So let's do another example. I'm not sure if I can finish this, but example 2. suppose just a minute. Find okay guys, right, so here it's similar to the example 1. The difference here is that you are given the joint CDF of the two losses. I mean, in example 1 we were given the joint survival function, right? So that's the difference here, right? So let's see how we can find. Okay, let's start with the CDF of U. Yes. So this is the probability that capital U is less than or equal to U. And I'm going to write this as 1 minus the probability that so this is 1 minus the probability that the minimum okay, so this is 1 minus the probability that x1 is greater than U and x2 is greater than U. Yeah, and this, as you know from the definition I gave you earlier, right, this guy here is the joint survival function at U comma U. Right, now the question here is the reverse. Now what you are given in the question is the joint CDF. Now what we need is the joint survival function. So we need to use the reverse relationship which I gave you earlier. Right, so the relationship that we need should express the joint survival function, right, in terms of the if you look back on the first video that I talked about this morning, you will see this is one of the relationships I gave you, that where it expresses the joint survival function in terms of the joint CDF, right? So now in order to find each of these guys, you just put, or in order to find this, you just put x1 equal to U, x2 equal to infinity. So it will become, I'm going to do it quickly because I'm running out of time. So this is what you will get, right? Then plus Okay. All right, guys. So you should simplify this. The 1 and the 1 will cancel. So this will be 2 divided by 1 plus okay. So this is the CDF of the minimum portfolio loss. Now to find the PDF, you differentiate this with respect to U. So the derivative of this with respect to U is going to be, let me do this quickly, okay? I hope you don't mind. So this will be plus plus 2 all right, I think, correct me if I'm wrong, but that's what I'm getting. So that's the density function of the minimum portfolio loss, right? Okay, guys, are you okay? Are you okay or not? Any questions so far? No? All right, so that's U. Now to find the second part, which is to find the CDF of V, which is the maximum portfolio loss. So we want this, yeah, which is the probability that capital V is less than or equal to V. So this is the probability that the maximum is less than or equal to V. Yeah. Oh, sorry. So this is the probability that x1 is less than or equal to V, comma x2 less than or equal to V, and this is the joint CDF at V comma V. Now the question, if you look at the question actually gives the joint CDF, which is this, right? So so what you have is this is equal to 1 divided by 1 plus E minus V plus E minus V. So this, which is equal to 1 divided by 1 plus 2 times E minus V. So this is the CDF of maximum portfolio loss. And finally the PDF of V is just the derivative of this. So if you differentiate with respect to V, you will get 2 you should differentiate this with respect to V, you get 2 I need to check my differentiation, just a minute. I might have this is what you get. I think the differentiation here, I don't think is correct here. You should differentiate this. This is the earlier part. You should differentiate it this minus. You get minus. So it should be no. That's what is it? That's the seed. Sorry, I got the wrong one. Which is this one. This one here. Is the differentiation here correct? I don't think so. This is minus, so this should be plus, I think. And here, and this should be minus here. So, sorry about this. I think this is the earlier part I did for you. if you differentiate this with respect to u, you should get, yeah, you should get plus and minus here. And for this, the derivative of this is this, I think is correct. Yeah, is that right? I think minus, yeah, I think it's correct. All right, guys, so those are the two examples I have the time for today. I hope you just understood the method, right, about how to apply the formulas to derive the distributions of S, U, and V. Okay. All right, so once again, thank you for handing in the quiz number 3. I will try my best to mark all of them today and return them to you today. Okay, if not, you will hear from me tomorrow. Okay. All right, I'll see you guys on Friday, right, for the tutorial sheet. So please look at the tutorial sheet if you have time. Okay. All right, guys, have a good day. You sick?
Yeah, this one.
I know, everybody got it.